Hi viewers, this is Dr. Jana and you are watching with me video on computer organization. This is the subject for second year level BTech people and it is a very fundamental and it is also a gate subject. So mainly we will be getting 5 to 6 marks in this gate. Fine. Now before we proceed for these computer organizations, what are the courses or what are the syllabuses are there for these things, that I will give you a brief description about that one. Once you see that, then we will proceed to that one. If you see here, the unit 1 will be designed like computer types, structure of computers, the functional units, basic operational concepts, the bus structures, performance, microprocessors and multi-computers. So this is part 1 of the unit 1. Then the data representation like the data type, fixed point representation, floating point representations, error detection and codes. So these are the things coming under unit 1 which we will be covering today. In the unit 2, we will be having subjects topics like basic computer organizations and design, here type of instruction, instruction codes, computer registers, computer instructions. Second part of these things we will have the register transfer language and also the micro operations we study there in the second part. The register transfer languages you will be studying the register transfer bus and memory transfer, arithmetic micro operations, logic micro operations, shift micro operations, arithmetic logic shift unit, then instruction cycle, memory reference, instruction input, output and interrupt, complete computer description, microprogram control, control memory, address sequencing, microprogram. So these are the things that will be coming under the 2. And unit 3 it is the central processing unit. Here we will study the general register organization stack and the difference between CISC and RISC, various addressing modes. Then the computer arithmetic, addition and subtraction, all the things are there. Then multiplication algorithm, division algorithm, floating point arithmetic operations and BCD adder. This is unit 3. Unit 4 will be studying like the input output organizations, all the things will see priority and the different peripherals. Then unit 5 the memory organizations. So this is about, and also the books you will be having Maurice Mano, 3rd edition, I think the Pearson and Apprentice of India. Then you can go for this Hampshire, that is the MGH, okay, McGraw Hill, and the reference book you can go for the William Sterling Computer Organizations and Architecture. So this was all about the syllabus especially for this computer organization, and we will be covering today the unit 1. The unit 1, if you observe here, we will have the what I told you, the syllabus especially for this unit 1, those are the things it is given it here. Now the very fundamental things or the confusion we come across, what is the difference between computer architecture and computer organizations. So even if we study some part of this computer organization in computer architecture and some part of this architecture in the computer organizations, but there is a very clear cut boundary between these two. So now let us see this computer architecture. It comprises logical functions such as instruction sets, registers, data types and addressing modes. These are the things usually we call it the computer architecture. Coming to computer organization, this consists of the physical units like circuit designs, peripherals and adders. So if you go in details regarding all the things, we can still have a thing here. The computer architecture and organizations, the difference you can see. The architecture describes what the computer does, what it does, that is the architecture, and the organization describes how it does. Okay, so this is the key difference. Second one, architecture deals with the functional behavior, whereas the computer organizations deal with the structural. Okay, organization deals the structural and architecture deals the behavioral part. Third one, architecture deals with high level design issues and organizations deals with low level design issues. Fourth one, architecture indicates its hardware, whereas organizations indicates its performance. Then fifth point, for designing a computer architecture, the architecture is fixed first. First we fix the architecture and based on that organizations is decided, right? Then the point number 6, computer architecture, this is the things already we have seen. This is also called the instruction set architecture. Organizations is frequently called micro architecture, right? Then The seventh point, it is same, already we discussed, I think. Then point number 8, architecture coordinates between the hardware and the software of the system, and organizations handle the segments of the network in a system. So this is the thing. Now let us see what are the computers and types. So we have the definition with us. Computer is a fast electronic calculating machine which accepts digital input, processes it according to its internally stored instructions or the programs, and produces the result on the output device. The internal operations of this computer can be depicted in the figure below. So if you see this diagram, you see 1, 2, 3 points are there. So we have divided into fetch, decode and execute. Remember, fetch, decode and execute. What is the fetch? Fetch is just retrieval of the next instruction from the memory. From the memory, what is the next instruction? That is retrieve. The retrieval of this instruction from the memory, we call it the fetch. Then by the program counter, and then increment the program counter. Okay, as indicated by the program counter indicates which instruction you have to fetch or bring or retrieve. Based on that you fetch it, and then the program counter is incremented. Then we go for the decode. Here decode is the bit pattern in the instruction registers. Okay, then what is the instruction and what instruction action is to taken, that is decided in the decoding part. Then third one, perform the action requested by the instruction, and this is the execute. Okay, decode means understanding what is the instruction to be executed, and third one, execute means execute the action requested by the instructions in the instruction register. Right, so this will be stored in the instruction register. Now this was the very fundamental things. Now coming to the computers and its classification, we can categorize the computer into various categories as stated below. One is the microcomputer, second one is the laptop computers, workstation, supercomputer, mainframe, handheld and also multi-core. At present what we are using the multi-core, that also I will describe. Now coming to the microcomputer, a personal computer designed to meet the computer needs of an individual. It provides access to a wide variety of computing applications such as word processing, photo editing, email and internet. So this we call as a microcomputer. The laptop computer, it is a portable, it is a compact computer that can run on power supply or a battery unit, and all components are integrated in one compact unit. It is generally more expensive in comparison to the desktop. It is also called a notebook. Right? So this was the general definition. Then coming to the workstation, it is a powerful desktop, we can say. We already studied about the desktop, but it is a powerful desktop computer designed for a specialized task, generally used for tasks that requires a lot of processing speed, and can also be an ordinary personal computer attached to the LAN. So even if sometimes we convert our system into a workstation while we are installing some server, etc. like that. Okay, server applications, software. Then coming to the supercomputer, a computer that is considered to be fastest in the world. It is used to execute tasks that would take a lot of time for other computers. For example, modeling the weather system, this genome sequence, etc. So we can refer the site www.top500.org. Now we can have some idea about what is the supercomputer. Then coming to the mainframe, this is the large expensive computer, and it is capable of simultaneously processing data for hundreds or thousands of users. It is used to store, manage and process a large amount of data that need to be reliable, secure and centralized. So for this type of applications, where hundreds of thousands of users want to access, then we can use the mainframe. Then you are going for this handheld, which is also called the PDA or the personal digital assistant, a computer that fits into a pocket, runs on batteries and is used while holding the unit in your hand. So just like the handheld, that's why I call it. Typically used as an appointment book, address book, calculator and notepad, like that. Then coming to the multi-core, it is having multiple cores like core 2, core dual core, i3, i7. So these are the multi-core. These are multiple cores, parallel computing platform. Many cores are computer segments in a single chip. So all the things designed and given. Then we generally first of all we must know what is the evolution, what is the generation of the various generation of the computers. The development of the technology used to fabricate the processors, memories and I/O units of the computers has been divided into various generations. So we divide it like this: the first generation, the second generation, third generation, fourth generation and beyond the fourth generation. Okay. So now what is this first generation? If you see, the first generation was designed during 1946 to 1955, right? So computers of this generation use the vacuum tube, and the computers were built using stored program concept, that is the ENIAC, 8SAC, IBM 701. Computer of this age typically use the 10,000 of vacuum tube. So this technology we are using that time, the vacuum tube, right? And they are bulky in size and slow operating speeds and short lifetime and also limited programming facilities. So this was the very first generation. It is in 1946 to 1955. Then 1955 to 1965, it came to the age of the second generation computers. Computers of this generation, they use the germanium transistor. Here we are using the transistor. Okay, that germanium is there. So using that one, the transistor is made. So these are the active switching electronic devices like IBM 7000, B5000, IBM 1401. So comparatively, this is smaller in size, about 10 times faster than the operating speed also, as well as compared to the first generation vacuum tube based computers. It consumed less power and fairly good reliability, and availability of a large memory was an added advantages in the second generation computer. Coming to the third generation computer, it started between 1965 and 1975. So the computers of this generation use the integrated circuits as the active electronics components like the IBM System 360, PDP, mini computers, and they were still smaller in size. They had powerful CPUs with the capacity of executing 1 million instructions per second MIPS. Okay, so 1 million or 1 MIPS they were used and used to consume very less power in comparison to the previous two. Then coming to the fourth generation, it started between 1976 and 1990. The computers of this generation, they use the large scale integrated chips, LSI chips, like the microprocessors as their active electronic elements, HCL Horizon 3, Wipro's Uniplus Plus, and HCL's BGB, PC, etc. They were coming under this for the fourth generation, right? They were more, they are using high speed microprocessors as CPU. They are more user friendly and highly reliable systems. They had large storage capacity, disk memories also. Then coming to the beyond fourth generation, 1990 onwards, specialized and dedicated VSLI chips are used to control specific functions of these computers, and modern desktops or PCs what you are using, they are coming laptops, modern PCs, laptops or notebooks coming under this thing, right? Then what is the functional unit? A computer in its simplest form comprises 5 functional units. What are they? First, the input unit, second one is the output unit, third one is the memory unit, then arithmetic and logic unit and control unit, right? Arithmetic, logic and control unit. So these are the units for 5 units, whatever you say. LU and CU you are taking it as 1, that's why 1, 2, 3, 4 is coming. LU1 and the control unit, that is also coming there. Then figure 2 you can clearly understand. Now if you see the left hand side, we are having the input, the IO. IO means input and output. One is the input, say using the keyboard, using the mouse, etc. The output monitor, printer, etc. The memory unit is centrally there. Then the processor there is the arithmetic logic unit and as well as the control unit. So if you count all this possible color or the orange color, 1, 2, 3, 4, 5. Okay. In this way we have divided all things. And the buses are there from input output to the memory unit and memory to the CPU. Right. So then coming to the input unit, the computer accepts encoded information through input unit. The standard input devices is a keyboard. Whenever a key is pressed, keyboard controller sends the code to the CPU or memory. So example, it includes mouse, joystick, tracker ball, light pen, digitizer, scanner, etc. All are the example of input unit. Then coming to the output unit, computer after computations returns the computed results or some error message, etc. via the output unit. The standard output device is a video monitor, LCD TFT monitor, other output devices like printer, plotters, all these things are coming under these output units. Then coming to the memory unit stores the program instructions or the code, data and results of this computer, etc. Memory unit is classified as a primary memory or main memory, then secondary or the auxiliary memory. Now we will be studying about this memory. The primary memory is a semiconductor memory that provides access at a high speed and runtime program instructions and operands are stored in the main memory only. The runtime program instruction, one is the instruction and operand is the data. Both they are stored in the main memory. That is the primary memory. Main memory is classified again into read-only memory and ROM and RAM. So read-only memory holds the system programs and firmware routine such as the BIOS, post, IO drivers, etc. That are essential to manage the hardware of a computer. So the moment we switch on with the BIOS, they want to check whether this part is there, that part is there, all things. Then we are coming to the main memory, second part is the RAM. RAM is termed as the read-write memory. Okay. So read-only memory means once it is written, without writing, we cannot read anything. RAM, this is the read-write memory or user memory that holds runtime program instructions and data. While primary storage is essential, it is volatile in nature. The RAM memory, you see, while you are working, that time RAM is active and you can use all things. The moment the power is gone, so RAM is invalid. Okay. While the primary storage is essential, it is volatile in nature and expensive. Additional requirement of memory would be supplied as auxiliary memory at cheapest cost. Then the secondary memory is non-volatile in nature. So these are the things you will be using like the hard disk and all things there. Then arithmetic and logic unit. ALU consists of the necessary logic circuits like adder, comparator, etc. to perform operations of addition, multiplication, division, multiplication, comparison, etc. All the things of any two numbers. So you will be using this ALU. Then the control unit coordinates the activities of all units by issuing control signals, and control signals issued by control unit govern the data transfers and then appropriate operations takes place, and control unit interprets or decides the actions by the performed. Fine. Then operations of a computer. The operation of a computer can be summarized as follows. So you see how a computer performs or work. A set of instructions called the program resides in the main memory. So you call about you are writing a program. So these are the set of instructions. They reside in the main memory of the computer. The CPU fetches those instructions sequentially one by one. So many things are there in the main memory. The central processing unit brings one from the main memory, then decodes and what are the instructions there to be done. First you understand that one, decodes them and perform the specified operations. This is the execution part on associated data operand like the array. Okay, and the processed data and results will be displayed on the output unit, and all active pertaining to processing and data movement inside the computer machines are governed by the control unit. So these are the various operations. If you see it here, the processor contains a number of registers. You can find the number of registers like the memory address register, memory data register, then program counter, the information register, instruction registers, all the things are there, and also memory buffer register like that MBR also will be there. Okay, so the processor contains a number of registers in addition to the ALU and the control circuitry. The instruction registers, this one IR, the instruction registers hold the instruction that is currently being executed. Which instruction is executed, that is held in the instruction register. Understand? The program counter just above that one. See, I am coming here. I don't know here. The instruction. Then is the program counter here. You can see the program counter keeps track of the execution of the program. What is the next instruction to be executed? That is there by the program counter. It contains the memory address of the next instruction to be fetched and executed. There are n general purpose registers R02. See, you can see it in the middle. R0 to Rn-1, you can see it here, R0 to accumulator to Rn-1. These are the general registers, okay, general purpose register which can be used by the programmers during the writing operations, right? So like that, these are the various registers we'll be using. The interaction between the processors and the memory and the direction of the flow of the informations, that is explained in the diagram. You see, main memory, see, address of an instruction will be there in the program counter try to fetch it from the memory address register. Address will be there in the memory address register, and the program counter keep track of all the things. What is the next instruction? It is to be fetched from this memory address register. Fine. Then it is sent to memory. Then it will go for the memory data registers. So it fetches the data Data means the operand. What is the data? And this instruction from this instruction registers. Then control the control. You can see it here just like relation here. It is coming here, here like this. The diagram is not clear. So this is the arithmetic logic unit. The interaction between the memory and the ALU is done like this. So memory is here and ALU is here, just like a V-shaped vessel. It is here. So this is the interaction takes place. Then we connect the bus structure. So group of lines that serve as connecting path for several devices is called a bus. Bus means it's not the school bus, college bus, artist bus, they are not like that. So these are the group of connecting lines, just like the wires. What it is, the integrated circuit, some lines are already pre-drawn. Okay, there. Group of lines that serve as connected path for several devices is called a bus. So one bit per line, in one line, one bit will pass. So individual part must communicate over a communication line or path for exchanging the data, addresses, and also controlling information. So in the you can see it here. So system bus input is connected, output is connected, memory is connected, process is also connected. A common approach is to use the concept of a register to hold the content during the transfer. So these are the things. Then the data representation, information that a computer is dealing with data, like the numerical data, numbers, integers and real numbers, non-numerical data like the letters, symbols, relationships between the data greater than less than. Then data structure like the linear list, trees, rings, etc. and program like the instruction. Okay, these are the data representation. And the numeric data representation, you can see here decimal number 00, and in the binary you are putting in 4 bit 000, in the octal 00. Octal means you see the maximum will be 07. And after that, so it is again coming 1 0 1 1, like that you can go for like this. So in octal 0 to 7 maximum 7 will be there. So coming the hexadecimal, so 0 to 9 maximum representation, then it will come A B C D up to F, because it is 16 bit hexa. So 0 to 15, F is 15 here, right? So decimal number system you can see 00 01 02 03. So all these things, and what is the binary representation also up to 15 it is given here. So this is an idea about that one. Then coming to the representation, it is the representation for integers only where the decimal point is always fixed at the end of rightmost point. It can be again a representation in the two ways. First one, the sign and magnitude representation. So in this system, the most significant or the leftmost bit in the word, it works as a sign bit. Okay, if the sign bit is equal to 0, the number is positive. The leftmost I am talking about. If the sign bit is 1, the number is negative. The simplest form of representation sign bit is the sign magnitude representations, and one of the drawback for sign magnitude number is addition and subtraction need to consider both sign of the numbers and their relative magnitude. Another drawback is there are two representations, that is the 0, that is plus 0 and minus 0 like that. Okay. Then we are using the 2's complement. 2's complement, it is, you are already acquainted with the DLD. So first we make the 1's complement. First by the number, some number is there. Say suppose example 0101. I am talking about 0101. What is the complement of that one? It becomes 1010. Okay. Then just this is the 1's complement. Then you just add 1 to that one. Then it becomes 1011. Right. So this becomes the 2's complement. Right. So this 2's complement, it is used for the subtraction purpose, because the computer does not understand subtraction, so it understands only addition, right? So subtraction, it is just like the suppose I want to deduct 3 from 5, then for 3 you have to make what is the 2's complement and add with 5 by the number system, then automatically it will give the result of subtraction. Similarly, multiplication is successive addition, and division is successive subtraction. So that means only computer understand the addition. From the addition we find what is subtraction, and from addition we find what is multiplication, and from subtraction again we find what is the division. So all things it is done there, so you can have this thing. Then we are going for the floating point representation. The floating point numbers are so called as the decimal or binary point float over the base depending on the exponent value. It consists of two components. One is the exponent, second one is the multiplier. For example, Avogadro's number 6.02 into 10 to the power 23. So in base 10 and the multiplier, you see it here. So why base 10? So 10 to the power 23. What is the base? Base is equal to 10. And the mantissa and the exponents are, mantissa is 6.02 and here it is 10 to the power 23 respectively. But computer floating point numbers are usually based on base 2. You understand? So 6.23 into the, it is base 10, but we have to convert into the base 2. Okay, so this is represented in a manner like this. So this is base 2. Okay, then these are the things in the floating point. Then we are going for the structure and function of a computer. If you see, computer is a very complex system for analysis, understanding and designing, identifying the hierarchical nature of most complex systems. A hierarchical structure unit, all things, it is the theory, you can study there, no problem. Then we are going for the second one, the structure and function. The way in which the computer are interrelated, we call it the structure. Function is the operations of each individual components as part of the structure, right? Then coming to the function of a computer, computer has the following four main functions. One is the data processing, then the data storage, data movement and control. So we can see one model, the Neumann model, or you say the IS Neumann model. So IAS means it is the Institution of Advanced Study. This started in the Princeton Institute, now the Princeton University, long back. Okay, so the Neumann is a mathematician. He suggested a model, and this is based on the stored program or load store, whatever you say. Stored program computer have the following characteristics. There are three hardware units like the central processing unit or the CPU, then the main memory and the I/O system, and the capacity to carry out sequential instruction processing a single data path between the CPU and the memory. This single path is known as the von Neumann bottleneck. Right. So you can see the central processing unit, the center one, the arithmetic logic unit, and this is the control unit. The left hand side is the memory unit, and the right hand side the I/O unit. Right. Then coming to the structure of the IAS, you can see it here. The left hand side I am giving the input output equipment, right hand side is the main memory, and we are having the various buses are also data bus and instruction bus and control unit. All things are there. So in the arithmetic logic unit, you are having accumulator, you are having MQ, you are having arithmetic and logic circuits, MBR memory of a register, then IBR, IR. This is also for register, the instruction register, program counter, memory address register, and the control circuits. All things are there. You can find one by one. Then the IS computer, already I told you. Coming to the performance, this is the most important measure of the performance of a computer, is how quickly it can execute programs. The speed with which a computer executes program is affected by the design of it, because you want the more speed, then you have to design in a better way, right? For best performance, it is necessary to design the compiles, the basic instruction set, and also the hardware in a coordinated way. The total time required to execute the program is elapsed time is a measure of the performance of the, because I say performance means in unit time how many works or how many instructions it can execute, that is the performance you call it here. So it is affected by the speed of the processor, the disk and the printer. The time needed to execute an instruction is also called the processor time. Just as the elapsed time for this execution of a program depends on the unit of the computer system, the processor time depends on the hardware involved in the execution of this individual basic instruction. This hardware comprises the processor and the memory, which are usually connected by the bus. Then these things you can have it here. Okay, and we are going to the processor clock also. The processor circuits are controlled by a timing signal. We call it as the clock. The clock designer the regular time intervals called the clock cycle. And to execute a machine instruction, the processor divides the action to be performed into a sequence of basic steps, and that each step can be completed in one clock cycle. That is the thing. Suppose the length P of a clock cycle is an important parameter that affects the processor performance. So what is the P here? The length P of one clock cycle is an important parameter. Okay. So based on this, we will be going for this one, the basic performance equation. If you see the next line, the basic performance T is equal to N into S by R. Okay. So clock rate is R. Okay. And the machines, one machine cycle instruction here, average number of basic steps, that is S. Right there. T is there, N is there, S is there. So you can get T using the equation N, S and R. Okay, N, S, R. What is N? The number N is the actual number of instruction executed. The actual number of instruction executed is N. Okay, then T be the processor time. So we can calculate the processor time. T is equal to N into S by R. Okay, so here the steps needed is S and R is the clock rate. So based on this we can find it that the performance measure we are using this equation. The spec rating is computed as follows. Spec rating is equal to running time on a reference computer divided by the running time on a computer under test. So if the spec rating is 50, then it's okay. So this was all about the unit 1. I hope it will be helpful to all the students who are preparing for this GATE exam as well as for this BTech secondary BTech exam. Thank you for watching this video. If you really like this video, please do share with your friends, and also don't forget to give a thumbs up as well as sharing with your friends. Take care of your health. Thank you. And based on the liking, I'll try for the second video. Thank you. Thank you all.